So guys, we are going to continue the discussion with respect to simple linear regression. We have understood, what is our main aim, what we are actually trying to do with the help of simple linear regression. We are actually trying to create the best fit line. But before we go ahead and understand the maths behind it, we really need to understand some of the notations that I'm actually going to use while explaining this entire machine learning algorithm. So let me go ahead and let me again consider this. So let's say that in the x-axis, I have my weight, and in the y-axis I basically have my height, and I do make sure that I populate some of the points which are like this. Let's say I have just randomly created some points, and these points basically mention our data set, right? Whatever data set we have, right? And these points only we are going to train our specific model, and what we are planning to do is that we are planning to create a best fit line in this, right? We are trying to create this best fit line. Now, in order to create this best fit line, we basically provide some equations to this best fit line. You can basically use the equation of a straight line like y is equal to mx plus c, or if you have seen some of the research paper, they may also use something like y is equal to beta 0 plus beta 1 multiplied by x, and you may also have another equation, which Andrew Ng also uses this specific equation when he teaches it, So he uses h theta of x, which is nothing but theta 0 plus theta 1 into x, right? So this equation. So in this entire simple linear regression that I'm actually explaining, again, some amount of credits, yes, definitely goes to Andrew Ng. Is quite amazing with respect to teaching any kind of topics. So I will also be using this specific notation, which is basically nothing but h theta of x is equal to theta 0 plus theta 1 into x. Okay. Now here, if I talk about x basically means my independent feature. Now in this particular case, it is weight. Okay. Now let's go ahead and let's try to understand what is theta 0 and what is theta 1. That is the most important thing that you really need to understand in this best fit line. Okay. And what is this h theta of x? Okay. So over here, let me write down the equation. H theta of x is equal to theta 0 plus theta 1 into x. Now, first of all, what exactly is theta 0? So theta 0, we can definitely say it as intercept. Why do we say it as intercept? In short, let's consider that if my x value is 0, then what will happen? If my x value becomes 0, then what happens? H theta of x is nothing but theta 0. Now this basically indicates that when my x value in this particular, in this line that I am actually drawn, right? Weight is my x in the x-axis, right? So when weight is 0, where does this particular line meet at the y-axis? Okay, so this particular line you will be seeing it meets somewhere here at the y-axis. So this particular point is nothing but this particular point is mentioned as intercept. So in short, what does theta 0 basically indicate? It basically indicates the intercept. That basically means when x is 0, what is the value of theta 0? Okay, so theta 0, wherever it is meeting the y-axis, that is basically called as intercept. Okay, so this is the first thing that you really need to know. Very, very important. Now let's go and understand what is theta 1. Theta 1 is nothing but it is called as slope or coefficient. Okay. Now, whenever I talk about slope or coefficient, what does this basically indicate? This basically indicates that with the unit movement in x-axis, suppose if there is a unit movement in x-axis, so if I try to plot this over here in the y-axis, we are just going to try to see that what is the movement with respect to the y-axis. So in short, what is this slope movement? Okay, so this is the movement that we are trying to see. So with the unit movement in the x-axis, what is the movement with respect to the y-axis? That indicates something called as slope. Okay, so very simple. This is also called as slope or coefficient. That is basically indicated by theta 1. Okay, suppose if I have many independent features, then this equation becomes something like this. H theta of x is equal to theta 0 plus theta 1 x1 plus theta 2 x2 plus theta 3 x3, like this up to theta n xn. So I can just write theta n xn. So this basically indicates that I have many features. So definitely I'll be having that many number of slopes like theta 1, theta 2, theta 3 till theta n. But here, since I just have one independent feature, so I'm just going to basically say that, okay, I have just one slope. Okay, one slope. Now, this is the basic understanding with respect to theta 0 plus theta 1 x, right? So x is nothing but my data points with respect to the x-axis. Now, one more very super important thing. Now, as I said that once we create our best fit line, whenever I get a new data point, let's say this is my new data point with respect to weight. Okay, with respect to weight, this is my new data point. Then how do I predict my height? All I do is that I try to project this over here and I try to basically see what is my y value. Okay, so this is basically my y value. So this point, I can say this is my predicted point, right? Predicted point. So whatever points I'm actually predicting over here, that is mentioned by h theta of x. So h theta of x is nothing but this is basically my predicted point. Let me give one more notation. This notation is nothing but y hat. Okay. So y hat I'll be using to basically specify my predicted points. Okay. Predicted points. Very simple. Okay. Now let's go and understand what exactly is error. Can I say error over here is nothing but the difference between, see, this orange point is nothing by y point, right? Y point, why I'm saying? Because over here in my data, right, this is my output. And let's consider this is x, this is y, right? So this basically is my output, right? And the points that I probably get, let's say this is my y point, and let's say with respect to this, my true point is my predicted point is somewhere here, right? So if I do this difference, then with respect to this specific data point, this should be my error, right? This should be my error. So error over here, nothing what I'm doing, I'm just subtracting y minus y hat, right? Y minus y hat. So in short, I'm just trying to find out the difference between these 2 points, and that actually specifies my error. Again, let me talk about like what is our main aim. Our main aim is to basically come up with a best fit line wherein when I try to calculate or do the summation of all this error, it should be minimal. If it is not minimal, suppose there is another best fit line that actually brings up this error or minimizes this error, I'm just going to select that specific best fit line. Okay. So I hope you have got the idea about error, what h theta of x is, what y hat is, and what all with respect to theta 0, what is theta 1 and all, right? So this was some of the notations that you really need to know when we start learning about the simple linear regression. Now, as we go ahead, we will try to understand how this best fit line is basically created, because we cannot just go ahead and randomly create many best fit line and then probably try to check each and every what is the error if once I do all the summation of the error, which is less, and then try to select a best fit line. No, this is not efficient. So we'll try to find out an optimized way wherein first of all we will try to create one best fit line, and then we'll try to rotate this best fit line by changing the values of intercept and coefficient, right? We are going to change this value of theta 0 and theta 1, theta 0 and theta 1, and then try to find out the best fit line with minimal error, right? So this is what we are going to learn, and we'll try to see how this optimization technique will basically happen and how we are going to perform all these things, right? So yes, I will see you all in the next video. Thank you.